Hi, this is once again, this is Dr. Palma, and today we are going to discuss another topic about research. And for this time, it's all about research and statistics. So, before anything else, allow me to invite you all, okay, to join in my webinar to earn 15 CPD units. You can contact me at contact@apalma.info, or you can email me at contact@apalma.info. So the accreditation number of my webinar is PTR 2021354125. Okay, particularly for this topic. Okay, so once again, this is Dr. Palma, and I'm a PhD in Development Research and Administration. I'm the academic head, author, and publisher recognized by the National Book Development Board of the Philippines. I'm a research consultant, international peer reviewer at Springer. My researchers, you can read them on Google Scholar, and I'm also a licensed professional teacher and a proprietor of Ardelo Palma Book Publishing. So these are my two books. The one, Statistics the Easier Way, is in progress, but the other one, Academic Research the Easier Way, is already published. So you can buy it online via Shopee, or yeah, you can directly contact me if you want to order. But anyway, okay, so let's proceed. So this the title of this program is Doing Academic Research the Easier Way. Okay, and for this one, the topic is research and statistics. Okay, the following, this is the learning outcome. Learners will learn what to employ as the appropriate statistical tools necessary for their research in the area of education. Okay, especially because the target, I specifically have the teachers or educators as the target for this program, but everyone can actually join. So let's review. Okay. Um, in my previous videos, okay, I was able to tell you that your academic research will never be off if it's founded by the appropriate philosophy and principle of scientific thought. So academic research should be both science and art, and that means that includes your creativity because it's an art. Okay. So we also discussed scientific thoughts, okay, or scientific thought. We started with rationalism. Okay, it is actually believing that the world can be understood by logical reasoning, because logical reasoning will allow us to lead to theory formulation. Okay, so a theory is a well-substantiated explanation of an aspect of the natural world that can incorporate laws, hypotheses, and facts. And in my book, I define theory as something that is having constructs and propositions. Okay, so we also discussed, okay, some learning theories. Okay, the following theories. Okay, I'll just run through. Okay. Okay, and so that's it. Okay, logical reasoning to formulate the theory. So empiricism, okay, rationalism was challenged by empiricism because observation should lead to knowledge. Okay, so it's not just enough to have a logical reasoning, okay, or to just use a reason, but of course we need to have systematic observation, measurement, experimentation that leads to, of course, the formulation of the scientific method. Okay, so but then positivism and constructivism and pragmatism challenge, okay, empiricism and rationalism, because according to positivism philosophy, theories need to be verified through observation for them to be undisputed. So this means this is going to be a combination of rationalism and empiricism. So meaning logical reasoning and scientific method combined. Okay, so but positivism was challenged by post-positivism that believes that the theories are hard to verify, but it's possible to reject false beliefs. Okay, but still, post-positivism is still a combination of rationalism and empiricism. But then, okay, this is just a sort of enhancement of positivism. Okay, so when we talk about positivism and post-positivism, I told you that it's equated or linked to or in line with the philosophy of quantitative research, and the philosophy of qualitative research is anti-positivism. Okay, but still qualitative research, okay, is incorporating, okay, empiricism and rationalism. So, but then pragmatism would like to combine or combines quantitative research and qualitative research. And that means we have here mixed method of research. Okay, that's pragmatism. Okay, so this is the bird's eye view, the flow of the discussion so far. Okay, and if you want to learn more, or if you want to um, know or understand the specific discussion about this, okay, I please visit my previous videos about this topic. Okay, so here, okay, the difference between qualitative, quantitative, and mixed method. Okay, so if qualitative research, if we are talking about qualitative research, it's inductive approach. Okay, so like it should start from specific down to general, or from empirical evidence to theory. That means, okay, we need to interview, okay, that's empiricism, philosophy, from the philosophy of empiricism, and to move forward to generalization or theory making, that's rationalism. Okay, so quantitative research is deductive, okay, in approach, okay, from theory down to hypothesis testing, or from general down to specific. That's logical reasoning, rationalism, and survey experimentation or scientific method. That's empiricism, part of the hypothesis testing. So I also discussed with you, okay, some examples on how to formulate your everything, okay, from theory down to statement of the problem. So please visit my previous videos about this. Now let's proceed to variables and their relationship. So these are the variables here. We have intelligence scores and bank savings from our previous examples, okay, or from our previous example. So this is the core of your hypothesis, this one, okay, your hypothesis testing. This is also the center of your statistical analysis. Okay, so intelligence scores, okay, leads to bank savings, or what's the relationship between intelligence scores and bank savings? Okay, so does research begin with finding what statistical tools to use? Okay, before anything else, I'd like to ask you this question. Okay, and let's answer that later. Now, if your answer is yes, that point of view may be accepted by many, but is not a sound practice associated with the fundamental philosophy and principle of quantitative research. If it's no, you are probably on the right track. Okay. Now, these are the steps to follow to formulating a methodology for quantitative research. Okay, you go back to your statement of the problem and creatively plan how you will answer them at the end of the study. Observe the relationship of your variables, and finally associate the appropriate statistical tools that you can employ to capture the relationship between or among the variables. Okay, so once again, okay, deductive reasoning is from general down to specific or special case, and inductive reasoning is from it started from special case down to the general principle. Okay, so I don't know what's the format in your normally in your, what's the required format in your institution about writing methodology, but in some schools or academic institutions, chapter methodology is in chapter 2, or methodology is found in chapter 3. But these are the common, okay, content, okay, you can find on the methodology. Okay, we have researchers worldview and research design. We have also data gathering and instrument. We also have data gathering procedure and statistical tools. Okay, let's begin with worldview and research design. Here, okay, in this section, you can explain or discuss your post-positivist worldview as a quantitative researcher, and explain or discuss your quantitative research design. Okay, when we talk about quantitative research design, we are referring to experimental design, survey design, and quasi-experimental design. Okay, now next, okay, we have the section for data gathering. So here you can write, okay, or explain about the respondents or the sample of the study. And what's the sample size? Okay, in computing for the sample size, you may use a sample size calculator online, or if you know parameters of your population, okay, you may use the following, like Cotts-Rand's formula, Yamayne's formula. Okay, and if you don't know much of the parameters of your population, you may use Sloven's formula. Okay, so we have here another is a sampling strategy for this section. Okay, you can use either random or non-random. Okay, it depends on the need of your study. Okay, so when you say random, that's probabilistic, and then random, that's not probabilistic. So note that the point of this is you want to establish, okay, external validity or generalizability of your study. Okay. In fact, this is associated with the philosophy of positivism or post-positivism. Okay, so we're down to data instrument. Will you use laboratory instruments for your experiment? Will you use a survey questionnaire for your survey? Will you use existing data or known as secondary data? These are the questions that you need to answer, okay, or you need to address if you are going to write your data instrument, or you're going to yeah, you're going to write your data instrument section. So here, you need to establish the internal validity and reliability and objectivity of your study. Okay, so like for example, for internal validity, you have to get your questionnaire checked. For example, if you're using a questionnaire, okay, you get it checked with its internal validity, the content. Okay, if it's valid, if it's related to the theory, in line with the theory, or if it really measures, okay, what it intends to measure. And are those contents there, okay, in the questionnaire consistent with measuring what they want to measure? Okay, you need to be objective there in also in doing it. Okay, so that what you can gather, the data that you can gather will reflect what's in actual or in the reality. Okay, so that's it. So that's our instrument. Okay, let's proceed to take a data gathering procedure. Here, you just explain the step-by-step process of how you came up with your instrument and how you will administer it. This is also part of establishing the validity and reliability of your study. And finally, okay, get down to the statistical tools. So just identify the appropriate statistical tools that will address the relationship of your variables. Do not name it yet, because you need preliminary data analysis to know what appropriate statistical tools to use. Okay, I'll just teach you later, okay, how to use it or how to do it. Okay, but you cannot name it yet because there are assumptions associated with the statistical tools. But then you can generally name what statistical tool to use. Okay, so I'll just give you an example later. So before anything else, okay, I'll just lead you to this example. For okay, suppose you have here, okay, data points. You have 4, 6, 7, and 8, and 20. And of course, 20, we know that it's an outlier. Okay, because majority of the data sets, we have only from 4 to 8 or 4, 6, 7, and 8. That's less than 10. But 20 is more than 10. So can you use mean here? Of course, if the mean, okay, if we compute 4, 6, 7, and 8, and 20 and divided by, if we add 4, 6, 7, 8, and 20 and divide them by 5, okay, we will get a mean of 9. Okay, so that is far from telling us the truth, okay, because majority of the numbers here, okay, are below below 9. Okay, so we cannot also use here multi-mode mode because we don't have mode here. Okay, it's not multimodal either way. So median, okay, is 7 because that's the center. Okay, if you want, okay, to have this data, or if you want to make sense with this data, okay, you can use the median. Okay, and that's free from the influence of the outliers. But when you use mean, okay, it's very influenced by the outlier, so it's probably not going to be good, okay, to use mean here. Instead, okay, I prefer to use the median. Okay, So that's what I told you, that you cannot just right away say that I am going to use mean in my statistics, okay? Or perhaps you just have to say the descriptive statistics will be used in analyzing the data instead of defining clearly, okay, what to use, like the mean, okay, here, because you need to have a preliminary analysis yet. Okay, prior to using what statistical tools to use. But of course, when you say descriptive statistics, that's general in essence. When you use mean, either mean or median, that's still part of the descriptive statistics anyway. So you're not actually, you're just still on track. Okay, so in that manner. Okay, so now, before you employ exact statistical tools, be sure to have preliminary investigation or evaluation of your data. That's what I'm telling you earlier. So statistical tools, as I've told you once earlier also, that they have assumptions associated with the data in order to appropriately capture its essence. Okay, so example here, we have, for example, linear regression. Okay, linear regression have the following assumptions in your data. The data should be have linear relationship, multivariate normality, no or little multicollinearity, no autocorrelation, homoscedasticity should be present. Okay, so that's it. So when you when you propose that you will use linear regression at the end of your study, okay, why not just say you will use regression analysis or any possible modeling technique? Okay, instead of telling that right away that you will use linear regression or simple linear regression, for example, or a multiple linear regression analysis. So because note that you really have to establish first, okay, the linear relationship. That's a requirement, okay, but it fails to achieve that, okay, probably there's no linear relationship in your data, so why use linear regression in the first place? So be sure to follow the assumptions of a certain statistical tool. So that's what I'm that's the reason why I was telling you earlier that it's too early for you in your proposal part. In your proposal, it's yet too early to determine, okay, what's the exact, okay, statistical to use. But you can actually just generally state that you will be using, for example, regression analysis or any modeling technique, okay, for your data analysis. Okay, so I hope I'm making myself clear here. Okay, so now before anything else, okay, let's proceed first to the functions of statistics. Okay, so we have here descriptive. So when we use mean, median, mode, you're using actually the descriptive statistics part of or the function of statistics. We have variance, standard deviation, sample size, computation, graphs, tables, etc. Okay, these are parts of yeah, they are components, or they are parts of descriptive statistics. And we also have in other book, okay, it's just only descriptive and inferential, but in my book I use probability as another function of statistics. But anyway, there might be a sort of argument, okay, for that, but I think, okay, inferential statistics is a combination of descriptive and probabilistic statistics. So therefore, okay, probability or a probabilistic function of statistics is really part of it, or really part of the functions of statistics. Now, let's focus on the inferential, okay, statistics. Okay, this is, as I've told you, a combined descriptive and probabilistic functions. Now, we have here, okay, three classifications or functions. We have test of difference, okay, the most familiar here, okay, of course, we have t-test, f-test, and ANOVA, and others. For the test of relationship, we have correlation, like Pearson and Spearman, and in test of association, we have regression analysis and other modeling techniques. Okay, so we have here basic inferential statistical tools. Okay, so in my book, okay, I define them as according to these classifications, number of groups, and whether they are parametric tests or non-parametric tests. So when we are talking about parametric tests, okay, these are statistical tools with assumptions on certain parameters. Okay, they're using parameters, and the assumption should be met. Okay, but If it's not so strict, okay, that's non-parametric statistics or non-parametric test. Okay, there's no assumptions. Okay, there are still assumptions, but they are not really strict with the parameters. So number of groups here, we have 2 independent groups, for example. Okay, we can use here. Okay, remember we are talking about here the test of difference. Okay, so if there are 2 independent groups here to be tested in with their means, okay, so we have t-test for independent samples, we have z-test for 2 sample mean for the parametric test, and for the non-parametric test we have chi-square test of homogeneity, chi-square test of goodness of fit, and Wilkinson rank sum test. Now in with having correlated sample or one sample group, okay, correlated sample or one sample group, okay, we have this is actually like suppose you have one section, okay, you are employing pre-test and post-test, okay, that could be correlated sample because you're just using one sample group before and after for that one group. So t-test for correlated samples or z-test for one sample group. Okay, so we can use here for non-parametric test, we can use Fisher sign test, McNemar's test for correlated proportions. What about you have 3 or more independent groups? Okay, you can use the ANOVA or F test. Or for non-parametric tests, you can use sign test for K independent samples or Kroskal-Wallis test and Friedman FR test for randomized block designs. Okay, so that's for the test of difference. Now, what about moving forward to intermediate and inferential statistical tools? We have here essential tools for test of relationship and association. So you can use person product moment coefficient of correlation if you are testing for relationship. With the use of parametric test, okay, you can use, or with parametric test, you can use person product moment coefficient of correlation. For non-parametric, okay, you can use chi-square test of independence, chi-square test of homogeneity, and Spearman rank order coefficient of correlation. But let's proceed to association test. Okay, one dependent and one independent variable. So we have here simple linear regression, Kendall's coefficient of concordance for non-parametric, and for one dependent and 2 or more independent variables. Okay, still association test. You can use the multiple linear regression analysis for parametric test, and non-parametric test. We have Kendall's coefficient of concordance W. Okay, so we have here some advanced inferential statistical tools. We have, for example, dependence techniques for multivariate analysis in terms of asking how many variables are predicted. So if there are multiple relationships of dependent and independent variables, you can use structural equation modeling. If there are several dependent variables in a single relationship, you can use canonical correlation analysis with and without dummy, or a multivariate analysis of variance. But if there's one dependent variable in a single relationship, you can use multiple regression, conjoint analysis, multiple discriminant analysis, and linear probability models. So these are just some suggestions that I may provide you, okay, or I'm providing you in my book, okay. So that's it. Okay, another is in continuation to some of the advanced statistical tools to use. Okay, what if the classification falls to asking where to find the structure of the relationship? So if it's among variables, you can use factor analysis or confirmatory factor analysis. Or if it's among cases or respondents, you can use cluster analysis. Or if it's among objects, okay, you can use multidimensional scaling or correspondence analysis. Okay, so let's begin first, okay, with the test of difference. I'm going to give you an example, but here in the test of difference, okay, you are always asking if there's a significant difference in the mean between 2 or more sets of data, okay, or even the median, okay, the median of 2 or more sets of data. Now, suppose you have a statement of the problem here, and that statement of the problem is found in number 3 question, or statement of the problem number 3. And suppose it says, is there a significant difference between students' intelligence scores when grouped according to their sex, financial status, and school type, public or private? So here, okay, you are asking for the difference of students' intelligence scores when you are going to group them in terms of their sex, financial status, and school type. Now, in your statistical tool section under your methodology, You might explain this or write this. To answer the question number 3 in the statement of the problem, the proponent will use test of difference as statistical tool for statistical analysis. So suppose that is in your proposal, okay, part of your proposal. So in your proposal, you just have to state test of difference, because it's too early to to tell your reader what type of test of difference you're going to use, because in the first place you just have to you need to undergo first, okay, with a preliminary data analysis for you to find out what statistical tools would fit. Okay, I mean, if the assumptions of a certain statistical tools are met. Okay, so here, okay, from that question, you have here your framework. Okay, that's a profile and then intelligence scores. That not the profile here is not actually an independent variable, but it's a moderating variable. Okay, so sex, financial status, school type. Okay, that's the moderating variable, and your dependent variable here is the intelligence scores. Okay, so that's not an independent. Okay, that's moderating variable. Okay, so the statement of the problem, another example, okay, suppose another statement of the problem, and it's also found in statement of the problem number 3, okay, and it asks, is there a significant difference between students' academic performance scores before and after a certain intervention program? Okay, or the length, okay, the length of an intervention program like home guidance program or reading program, etc. So in your statistical tools section under methodology, you can explain this. To answer the question number 3, the statement of the problem, the proponent will use test of difference as statistical tool for statistical analysis. So this is here, the length of reading program is an intervening variable because that's an intervention, okay, program. And the dependent variable here is we have academic performance scores. Okay. Test of relationship, okay, that's the second part, okay, and it usually asks if there's a significant relationship between 2 or more sets of data or variables. So suppose another statement of the problem is found in a statement of the problem number 3. Is there a significant relationship between intelligence scores and bank savings of the respondents? So you may answer this, or you may use this or write this in your methodology. To answer the question number 3 in the statement of the problem, the proponent will use test of relationship as statistical tool for statistical analysis. So this is your framework here. Okay, we have two-sided arrow here. Okay, the double-headed arrow, intelligence scores and reading program, the variable 1 and variable 2. Here you don't, okay, specify which is an independent or dependent variable, because this is not causation in the first place. Okay, the test of relationship like correlation, okay, is not causation. Okay, it's just just trying to establish if there's a relationship, perhaps in most cases a linear relationship between intelligence scores, for example, or the reading program. So you just have to state variable 1 and variable 2. Okay, so now let's proceed to test of association. So here, okay, you are concerned of knowing how much is the effect of the independent variable to the dependent variable, or how the independent variable affects the dependent variable. Okay, so here, okay, suppose you have a statement of the problem here, question number 4, which of the indicators of intelligence scores influences students' bank savings? Or sorry, respondents' bank savings. So in your methodology, okay, you may explain this. To answer the question number 4 in the statement of the problem, the proponent will use regression analysis or other applicable modeling techniques. Okay, so here's the framework. So you just notice, okay, you have here now your independent variable and dependent variable, and one headed arrow, okay, moving forward to or pointing to bank savings, okay, from intelligence scores to bank savings. Now, intelligence scores here, your independent variable, as I've said, okay, and based on the theory, okay, the intelligence scores could be explained through these indicators. We have analytical, creative, and practical. And which of these indicators, okay, affects, okay, the bank savings? Okay, if we increase, okay, analytical ability by 1%, okay, how much percent in the bank savings will be added? In creative and practical, okay, it's the same thing. So I mean, it's the other, yeah, it's also the same question. So that's it. Okay, that's causation. So here we have the mediator variable or the mediating variable. okay, of the independent variable and independent variable. So suppose we have an example like this, okay, temperature, okay, is what? Leads to soil moisture, and soil moisture leads to soil respiration. Is soil moisture a mediating variable between the temperature and soil respiration? Okay, that's possible. Okay, and based on the theory, it's possible. Okay, conceptual framework, another conceptual here. Okay, we have level of risk of infection with COVID-19 and classification of people eating and non-eating garlic. Okay, that's moderating and dependent variable. So notice the arrangement, okay, of your variables here. And you also have noticed that we use square or rectangular because that's variables. Okay, if it's construct, okay, we just have to use, okay, circle or something round, okay. Okay, so sales and advertising cost. Okay, that's the relationship between sales and advertising cost, and how much advertising cost will lead to a certain amount of sales. Okay, yeah, that's prediction. Okay, that's causation. So let's review. Does quantitative research begin with finding what statistical tools to use? In philosophy and principle, why the use of certain statistical tools makes sense in quantitative research? What's the connection of the use of appropriate statistical tools to the attainment of the validity, reliability, and objectivity of the study? Okay, so our next webinar, okay, may I just plug in, okay, is about research and statistics, okay, specific this time. It's about worldviews and scientific thought, constructs, propositions, variables, and hypotheses, framing the backbone of quantitative research. And we will also discuss research and descriptive statistics specifically. We also have to discuss research and inferential statistics specifically as well. And we will also use research. We will also proceed to topic on research and SPSS. Okay, we have two parts here, part 1 and part 2, because we'll be using actual SPSS, okay, for the analysis. Okay, so that's it. I hope you will join in my next webinar. It's about research and statistics. So join my webinar to earn 15 CPD units, and you may email me if you want, okay, to join. You may email me at contact@apalma.info. So once again, these are my, take a picture, take a look at my contact details, okay? So that's it. I have my website at www.apublishing.com and https www.apalma.info. Okay, you can search me on my YouTube channel. You can search me on YouTube. Okay, my YouTube channel is Artelo Palma PhD Life Ideas Books, and I also have my Shopee store. It's Fun with Learning Bookshop. Okay, so thank you very much. Okay, thank you. I hope you have learned many things today. See you in my next video. Thank you very much. Have a great day ahead. Okay, stay safe, healthy, and blessed, everybody. Bye-bye.